All right, now we got Unit 4. So Unit 4 was all about quadratics, and hopefully this unit is a unit that you feel confident in leaving Algebra 2. It was a pretty strong unit for a lot of us. It wasn't your first introduction to quadratics, but it was the moment when all of the information there hopefully came together for you. So here's a visual. Quadratics are the parabola-shaped graphs. The parent of all the quadratics is f of x equals x squared. So some of the key features, it could either open up or down. It is degree 2. That means according to Gauss's work, it should have at least 2 roots, both real and imaginary, which we'll get to in a moment. It's possible that it has a y-intercept somewhere. Yeah, it will. I'm sorry, that sounded weird. It has a y-intercept. It has an axis of symmetry, cutting this symmetrical parabola figure in half. And it has a vertex, that moment when the parabola shifts directions. Maybe it was decreasing at the vertexes where it all shifts, and suddenly now it's increasing from there. So to find the x value of that vertex, you could plug in negative b over 2a. The b and the a, again, are going to come from something we'll talk about in a second. And then that would be your x value of the vertex. To find the y, you would substitute this information into the original function, and out could pop your y value. Kind of another key feature here, but it's almost so important it's a point of its own, are the solutions, the x-intercepts, aka roots, aka zeros. I say aka a lot because we can use all 4 of these words possibly to describe this place, the place where the parabola crosses or intersects with or touches the x-axis. So some possibilities, you could have one real root, one moment where that parabola touches the x-axis. You could have 2 real roots. Here we've got 2 locations where the parabola crosses the x-axis. And it's also possible to have no real solution, like this parabola is just floating up in the air. It could float below as well if it opened down, and it could have no real roots. But then we were able to solve that problem by introducing the complex or the imaginary world of numbers. This is an entirely kind of separate number system that exists using I. And I was defined to be the square root of -1, allowing for a little bit more work there when solving and discussing the roots here. So I also wrote down with I, as you know, the pattern that we talk about a lot. I's powers of I, if you multiply I by itself again and again and again, like for example, I to the 5th, it ends up kind of equaling something that we already saw previously in the pattern of those powers. So we talk about I, -1, -I, and 1, kind of cycling through the pattern. And I just put those here on my kind of review board so that I wouldn't forget the powers of I. You also learned about that in Unit 4. So there are some forms of quadratics here, 3 really that are important in our studies. We talked about standard form, which is the ax squared plus bx plus c. If you're going to use the quadratic formula, it's a requirement that your quadratic first be in this format with the a, b, and c. I didn't even put the quadratic formula on my whiteboard, y'all. That's crazy. But you know it. It's the one that I sing to the song, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Yep, that's the one. Okay, so standard form. That's our a, b, and c, the coefficients on every term. Something else that was important was factored form. This is where you still have that a, that leading coefficient out front, but you have x minus a root, x minus another root. So there is a little bit of sign changing to go on here, but factoring something that's given to us in this format, turning it to this format by factoring was really useful for finding roots. Something like this picture down here, you could figure out exactly where those 2 locations are by simply using the algebra process of factoring. Factoring was a big deal in Unit 4. The last form that was important was this vertex form. It has x minus h squared plus k, and the h and the k come together to create the coordinate of your vertex. With transformations, this format is perhaps most important. You can do all of these things when you transform a parent function, which is again something else that I introduced you to in Unit 4. That was a quick recap of perhaps one of the most important units all year.